the application layer. In that, principles of network applications. Then in principles of network application, you are going to study about web and HTTP, FTP, some electronic mail, that is SMTP, POP3, IMAP, DNS, P2P application, then socket programming with UDP and TCP. Okay, so here we will see one by one. The first thing is principles of network architecture. See, the network application development is writing a program that runs on different end systems and communicate with each other over the network. For example, the web application, there are two distinct programs that communicate with each other. The browser program running in the user host and the web server program running in the server host. So there are two kinds of architecture we have discussed. One is client and server architecture and another one is peer-to-peer or P2P architecture. Okay, this is one of the example. We are writing code in one of the thing and running in the another systems. Each will be having its own layers, right? Application layer to the physical layers. Then the two kinds of architecture, one is client server architecture. In the client server architecture, there is always on host, okay, that is called server, which provides the service when it receives a request from many other hosts called as clients. For example, web application, web server services, request from the browser running on the client host. When the web browser receives a request for an object from the client host, it responds by sending the requested object to the client host. In the client server architecture, client do not directly communicate with each other. This is the important point. So client to client communication is not possible. Server has a fixed, okay. So client to client is not possible. The server has a fixed well-known address that is called IP address. Because the server has a fixed well-known address and because the server is always on, the client can always contact the server by sending the packet to the server IP address. Some of the better known application with the client server architecture includes web, FTP, telnet and email. Okay, in a client server architecture, if you go, a single server host is incapable of keeping up with all the requests from the client. For this reason, the data center housing a large number of hosts is often used to create a powerful virtual server. The most popular internet service such as search engine, for example, Google or the Bing, or internet commerce if you go Amazon, email, web-based email like Gmail, Yahoo Mail, social networking, Facebook, Twitter, we are using daily, employ one or more data servers. Got it now? So this is about the client server architecture. You can see the architecture, the diagram. So the main part is client to client communication directly. It is not possible in case of client and client server architecture. Next, we'll move on to peer-to-peer architecture. That is P2P architecture. P2P architecture, there is a minimal dependency, dedicated servers in the data centers. The application employ a direct communication between the pairs of intermittently connected hosts called as peers. Now, each and every host we are going to call it as peer. So they are not owned by the service providers, but instead desktop, laptops controlled by the users, with most of the peers residing in homes, universities, and offices. Okay, many of today's most popular and traffic intensive applications which are based on P2P architecture. So the application, either it may be a file sharing, that is BitTorrent, or internet telephony, that is Skype, or IPTV. You can go with the example of Kankan, PP Stream, all those things. So let's discuss some of the features of P2P architecture. One is called self-scalability. So for example, in P2P file sharing application, although each peer generates the workload by requesting the file, each peer also adds a service capacity to the system by distributing the file to other peers. So that is called self-scalability. And whenever there is a new peer enter in, right, bring a new service capacity as well as that service capacity will be distributed. Okay, that is called self. Next is cost effectiveness. So P2P architecture are also cost effective since they normally do not require significant server infrastructure as well as server bandwidth. So let's, by using this, we'll have P2P teachers face some three major challenges. Let's discuss the challenges. First challenge is ISP friendly. So internet service provider. Most of the residential ISPs have been dimensioned as asymmetrical bandwidth usage. That is for much more downstream than the upstream traffic. But P2P video streaming and file distribution application shift upstream traffic from the server to the residential ISPs, thereby putting a significant stress on the ISP. Future P2P applications needs to be designed to that they are friendly to the ISPs. Next, second task is challenge is security. Because of their highly distributed open nature, P2P applications can be a challenge to the secure. So incentives. The success of P2P, future P2P applications also depends on convincing user to volunteer bandwidth, storage, and computational resources to the application, which is the challenging of incentive design. So next part is process to communication. So process communicating. A process is nothing but a program or the application under execution. So when the process are running on the same or the different systems, they communicate with each other with inter-process communication using the rules that are governed by the end systems operating systems. Process on two different end systems communicate with each other by exchanging the message across the computer network. The sending process creates and sends the message into the network. Receiving process means which will receive these message and possibly respond by sending the message back. So in that way we can have client and server process. A network application consisting of pair of processes that send message to each other over a network. For example, in web application, client browser process exchange message with the web browser process. In the context of communication session between the pair of process that initiate the communication is labeled as client. The process that waits to be contacted to begin the session is called as server. So this is about client process as well as server process.